Earth Systems 3209. Unit 4, The Forces Within Earth. References for this unit can be found in Chapters 4, 15, 16, and 19. And also references can be referred to in Appendix A and Appendix B of the Curriculum Guide. Unit 4, Topic 2.8. This topic will look at the geology of Newfoundland. This topic focuses on describing the geology layout of the island of Newfoundland, and also will focus on the core STSE, entitled The Geology of Newfoundland and Labrador. When we look at the plate tectonics and how plate tectonics relates to the island of Newfoundland, the geological formation of Newfoundland is strongly influenced by plate tectonics in the past 500 million years. About 500 million years ago, the central portion of North America was under a warm tropical sea called the Iapetus Ocean. Europe and Africa bordered the Iapetus Ocean to the east, and North America bordered the Iapetus Ocean to the west. Over the next 150 million years, that was 350 million years ago, forces within the Earth mantle slowly carry these continents on a collision course. As the continents drifted together and collided, the ocean floor was squeezed and then pushed up to form the Appalachian Mountains. So if you look at the diagram below, we see that the North American plate was located to the west. The African plate, mainly, was located to the east. And in between was a closing ocean floor. Within this closing ocean floor, there was many volcanic islands forming on the overriding plate, which is called a volcanic island arc. Also on this diagram, we see the Northern Peninsula and the Avalon Peninsula outlined on the actual plates. Newfoundland did not exist at this time, but these are the portions of the tectonic plates which would later form Newfoundland. So the plate of North American plate and the African plate was on a collision course with the Iapetus Ocean closing in the middle. Once the collision occurred, the remains of a mountain range now existed throughout the central and western portions of what would become Newfoundland, and the northernmost part of the Appalachian Mountains was located in North America. This range continues throughout most of the eastern portion of North America and continues over into the British Isles and up into Norway. So if we look at the diagram down below, we see that the North American plate, which is located on the left side, and the African plate, which was located on the right side of Newfoundland, and the Appalachian Mountains is the remnants of a closing ocean floor some 350 million years ago. This now is seen in the rocks within Newfoundland and Labrador. An area called the Tablelands in Grossmoor National Park has rocks that were once part of the Earth's mantle, but were pushed on top of Earth's crust during the collision of the two tectonic plates approximately 350 million years ago. These sightings are called Ophiolite complexes and represent the ocean floor profile resting on land, and they are rarely seen on Earth's surface. If we look at the diagram, we see that an area on the western portion of Newfoundland called the Tablelands experience or display some of these Ophiolite complexes, and also there's an area up on the northern portion of the Northern Peninsula which also display the Ophiolite complexes. Approximately 225 million years ago, the forces in Earth's mantle that brought the continents together suddenly reversed and slowly began to pull the plates apart. The divergent boundary responsible for shifting the plates rifted within the African plate and caused the plates to drift apart, leaving a small section of the African plate behind. When we look at the diagram below, the collision boundary before was located where central Newfoundland is today. When the convection in the mantle reversed, it did not start up at the place where it was actually colliding in the past. Instead, the convection currents reversed within the African plate, and it separated the African plate some 500 to 1,000 kilometers to the east. And this rifted the African plate, and it formed into a new divergent boundary. And this divergent boundary today is what we call the Mid-Atlantic Ridge. During this process, a small bit of Africa got left behind. When you stand on Single Hill in St. John's, you are standing on rocks that are identical to the ones in the country of Morocco in North Africa. The eastern part of Newfoundland was once a part of the African plate. So when we look at the geology of Newfoundland, the geologic layout of Newfoundland shows on the western portion of the island portion of Newfoundland, we have what's called the Western Zone. This Western Zone has been a part of the North American plate for the last billion years or so. Within central Newfoundland, we see the Central Zone, which is called the Central Mobile Belt. This area is the remnants of volcanic island arcs and the remains of an ancient diaphanous ocean floor that have once closed when the African plate collided with the North American plate. The eastern portion of the island part of Newfoundland, called the Avalon Zone, was once a part of the African plate, which remained attached to the North American plate when Pangea split some 200 million years ago. So when we look at the geological layout of Newfoundland, we see the Western Zone, which is the remnant part of the North American plate that existed approximately 1 billion years ago. We see the central portion of Newfoundland, which is the Central Mobile Belt, and this was the ancient diaphanous ocean. And we see the eastern section of Newfoundland, which was once part of the African plate that got left behind when convection currents rifted within the African plate, and it left a small portion of the African plate behind when Pangea broke apart approximately 200 million years ago. So in review, we see the Western Zone, which is the North American plate. We see the Central Mobile Belt, which is the center part of Newfoundland, which was the remnants of the old ancient ocean floor, the diaphanous ocean. And we see the eastern portion of Newfoundland, called the Eastern Zone, and this was once a part of the African plate that got left behind. When we look at the geological layout, we also see some dominant faults that run from the northern part of Newfoundland down to the southern part of Newfoundland. Separating the western platform or zone from the Central Mobile Belt is the Bay Vert, the Cape Ray Fault. Separating the Central Mobile Belt from the eastern platform or the eastern zone is the Dover Fault that stretches from Dover out near Gambo to Hermitage down on the south coast of Newfoundland. So these two dominant faults actually separate the different zones of Newfoundland from the western zone to the Central Mobile Belt to the eastern zone in the east. Let's look at some examples that cover this topic from past public exams. Example number 1 reads, which area of the island of Newfoundland is composed of rocks similar to the ancient ocean floor? So if we look at the ancient ocean floor, that would be called the Central Mobile Belt, and that would be located in the central portion of Newfoundland, with the western portion that was the part of North American plate, and the eastern portion will be a part of the African plate. So the answer here, the ancient ocean floor, exists in the central portion of the island of Newfoundland. Example number 2 reads, when the Proto-Atlantic Ocean closed many years ago, That's the old ancient Iapis Ocean. Which mountain chain was created on the east coast of North America? So if we look at the east coast of North America, which focuses on the eastern seaboard, ranging from New York up through Massachusetts into the eastern provinces of Newfoundland, Nova Scotia, and Newfoundland, and then stretches over to the British Isles in Europe. We see that the ancient mountain that existed at that time was the Appalachian Mountains. So the answer to example number 2 is B. Your turn. Take the time and stop the recording, and you can complete the following question by preparing an answer. And the correct answer that's prepared will be on the following slide. Let's look at the question below. Use the diagram and your knowledge of the theory of plate tectonics to explain how the 3 geologic zones of the island portion of Newfoundland and Labrador were formed. So if we read the question carefully, the question asks, by referring to the diagram to the right and your knowledge of plate tectonics, explain how the island portion of Newfoundland formed millions of years ago. So when we look at the answer to this question, the answer would focus on, it is thought that the geology island of Newfoundland resulted long ago when the Iapis Ocean was closing. The North American plate collided with the African plate, and as a result, a portion of the Iapis Ocean was sandwiched in between the 2 colliding plates. Zone A in the diagram above is referred to as the western zone, and this zone was a part of the North American plate. Zone C is referred to as the eastern zone, or the Avalon zone, and it's thought to be a part of the African plate that was left behind once Pangaea rifted some 200 million years ago. And Zone B is referred to as the central mobile belt, and it's thought to be once a part of the ancient Iapis Ocean that was sandwiched in between the North American plate and the African plate as the Iapis Ocean closed. So Zone B, the central mobile belt, mainly consists of igneous rocks, similar to that of the ocean floor, and of volcanic island arcs. In summary, when we look at the geology of the island of Newfoundland, Newfoundland is divided into 3 geologic zones. We have the western zone, which is also referred to as the Humber Zone, which is the old remnants of the North American plate. We have the central mobile belt, which is located in the central portion of Newfoundland, and this zone is the remnants or remains of an ancient ocean floor with volcanic island arcs. And the eastern zone is thought to be the eastern portion of Newfoundland around the Avalon, and is thought to be the remnants or the remains of a portion of the African plate that got left behind when Pangaea rifted apart some 200 million years ago. So the western zone is a part of the North American plate. The central mobile belt is the remains of an ancient ocean floor, and the eastern zone is a portion of the African plate that was left behind once Africa rifted some 200 million years ago. Note, Newfoundland formed as a result of plate tectonic activity over the past 500 million years. This activity formed the Appalachian Mountains and left a part of the African plate behind as a part of the eastern Newfoundland. So this slide sums up the main points in this presentation.